Every single day, tens of thousands of airplanes crisscross the globe, flying along these invisible highways in the sky. And the whole system is built on just incredible precision, a strict set of rules and constant communication. But on November 12, 1996, over a small village in India, that system didn't just bend, it broke, in the most catastrophic way you can imagine. Today we're going to deconstruct the anatomy of this tragedy to understand how it happened, and just as importantly, how its lessons ensured it would never happen again.
Just imagine hearing that report crackle over the radio to Delhi Air Traffic Control. It's chilling. That was the very first sign that something had gone terribly, terribly wrong. Two massive passenger jets with 349 people on board had just blinked off the radar, and in their place, a horrifying fireball lighting up the night sky.
So here's how we're going to break this all down. We'll start with the collision itself, then we'll get into the basics of how these highways in the sky are supposed to work. We'll meet the two planes and their crews, count down the final, fatal minutes, and then we'll dig into the investigation to uncover the truth. And finally, and this is the crucial part, we'll look at the vital safety lessons that came out of this tragedy.
Okay, let's put ourselves right there in the immediate aftermath. You have two aircraft, one coming in to land, one just taking off from Delhi, and they're just gone. On the ground, it's total chaos and confusion. But for anyone looking at the sky, a terrible truth was already becoming clear.
Let that number sink in for a second. 349. This wasn't just an accident. It was, and it still is, the deadliest mid-air collision in the history of aviation. There were no survivors, not a single one. The scale of this tragedy just sent shockwaves across the entire globe.
And this is the real head-scratcher. This is the central mystery that investigators were faced with. I mean, think about it. Both planes were talking to the same air traffic controller. They were both given specific altitudes that should have kept them a safe distance apart. So in the vast three-dimensional emptiness of the sky, how on earth did they end up in the exact same piece of air at the exact same time? To really understand what went so wrong here, we first have to understand how things are supposed to go right, day in and out. Because the sky isn't just empty space, right? It's this meticulously organized network of invisible routes that really are just like highways on the ground.
Okay, so the most basic rule of this whole system is keeping planes separated vertically, and we do that using something called a flight level. It sounds technical, but it's super simple. A flight level of, say, 140 is just a shorthand way of saying 14,000 feet. It's a universal language that keeps pilots and controllers on the exact same page.
Now this is where the system is just brilliantly simple. If you're on one of these airways and you're flying east, you get assigned an odd altitude, like 35,000 feet. If you're flying west, you get an even one, like 36,000 feet. Just like that, this one simple rule automatically builds in a 1,000-foot safety buffer that prevents head-on collisions. It's one of the absolute cornerstones of air safety.
So if the system is designed specifically to keep planes apart, how did these two end up on a collision course? Well, let's introduce the two aircraft whose paths were, tragically, about to intersect just west of New Delhi. On one side, we have Kazakhstan Airlines Flight 1907. It's in Ilyushin L-76, and it's on its way down to land in Delhi. And on the other, you've got Saudi Arabian Airlines Flight 763, a huge Boeing 747, climbing out after takeoff. So you've got them on the same airway, heading in opposite directions, a scenario this system was literally built to handle safely, thousands of times a day. And right here, this is where we see the first major crack in the system's armor. The entire flight crew on the Kazakh plane spoke Russian, so every single instruction from the English-speaking controller in Delhi had to be heard by a dedicated radio operator who then had to translate it and pass it on to the pilots. This created a built-in delay and a huge potential for misunderstanding in a world where every single second counts. Okay, we're now entering the final 5 minutes before the collision. And what's so chilling is that if you listen to the air traffic control tapes, everything sounds completely normal, totally routine. But under the surface of those calm voices, a catastrophe is silently unfolding. The air traffic controller gives crystal clear instructions. He tells the descending Kazakh plane to stop at and maintain 15,000 feet. He tells the climbing Saudi jet to stop at 14,000 feet. Both crews read back the instructions. They confirm they understand. You look at this timeline, and on paper, the system is working exactly as it should. So, this is the whole ballgame right here. A 1,000-foot vertical buffer was officially established between these two planes. This isn't a suggestion, it's standard procedure. This is the margin of safety that was supposed to let them pass each other, completely safe and sound.
The controller even gives them one last warning, a final safety net. He tells the Kazakh crew about the oncoming 747. But because of the language barrier, the radio operator actually had to ask him to repeat it. By the time he finally translated that warning for the pilots, it was already far too late.
When the investigators finally recovered the flight data recorders, what we call the black boxes, from the wreckage, the absolutely horrifying truth of those final moments was laid bare. The problem wasn't the instructions from air traffic control, it was how they were carried out in the cockpit. And boom, there it is. This slide just cuts right to the heart of the disaster. At the exact moment the Kazakh radio operator told the controller they were at 15,000 feet, the plane's black box showed they were actually at 14,500 feet and still going down. Fast. They didn't just miss their assigned altitude, they flew right through it into the path of the 747. You see, a disaster like this is almost never just one single mistake. It's a deadly chain of events, a cascade of failures. The investigation pointed to the Kazakh pilot's failure to level off as the main cause, probably from not paying close enough attention to his instruments. But that was made so much worse by the language barrier that delayed that crucial final warning. And maybe most critically, the controller in Delhi was basically flying blind. His radar showed him where the planes were on a map, but it didn't show him their altitude. He had no way of knowing they were in danger until he saw that fireball.
In the wake of such an unbelievable tragedy, the entire aviation world was forced to ask a really tough question. How do we make sure this can never, ever happen again? And the investigation's findings led to some of the biggest safety upgrades in modern history.
You know, this crash became a painful but incredibly powerful catalyst for change. The industry realized that just relying on human voices and outdated technology wasn't enough. There had to be a technological safety net.
And that safety net is an amazing piece of tech called TCAS, the Traffic Collision Avoidance System. Basically, it's an onboard computer that lets planes talk directly to each other without any humans in between. It's always scanning the sky, and if it senses another plane getting too close, a calm automated voice will say, "Traffic, traffic." And if they get even closer, the system takes charge. It'll yell, "Climb, climb" to one pilot, and "Descend, descend" to the other, instantly coordinating a life-saving maneuver. So the legacy of Charkhi Daudri is literally written into the rulebook of modern aviation. TCAS is now mandatory on commercial planes everywhere. Strict English proficiency tests are now required for all international pilots, which gets rid of that communication delay. And airports all over the world have upgraded their radar so controllers can see a plane's altitude in real time.
The tragedy over India really was a story of human error, but it was amplified by the limits of both language and technology at the time. The solutions that were put in place have, without a doubt, saved thousands of lives since. But it does leave us with a really important question for today. As our machines get smaller and more automated, how do we make absolutely certain that the communication between people and technology is flawless, especially in those critical moments when everything is on the line?